So let us do my question here. The question here in 2024 to 2024. This was the question found in the physics national exam 2024 as the finding out electric currents flowing through the circuits shown above. So here we have the circuits and we have to find out the current 1, current 2 and current 3. So we put here a loop just to find out this by loop, and this is a loop 2 and this is a loop what? A loop 1. So let's consider for the loop 1. For what? For the loop 1. For the loop 1, let's consider this for the loop 1. So for the loop 1 is, as we know, if the loop is coming from positive to negative, that means the electromotive force would be also equal to negative 20 volts. So here for the 1 ohms, here if the loop is opposite to the current flowing through the circuit, that means the potential difference will be equal to positive. That's why here we will add what? IE1, and for this one also the current is opposite on the loop, so that's why we have also positive 0.5 I2, and also we'll add again 0.5 I2, and also we will be having here as because this is this loop is coming from what? From negative to positive. That's why we have also a positive electromotive force, which is 20 volts. And also after getting this, we'll go here for this 0.5, and also the current is upward and the loop is downward, so this is opposite. So we have also positive 0.5 I1, and also we have again 0.5 I1. This is for the what? This is for the loop what? This is for the loop 1. So we can simply do what? We can simply cancel this one. Can cancel this one because it is the same and opposite. Here also we can cancel this one, and also after cancelling this one, you can simply having what? Finally we're gonna have 2 I1 plus what? Plus I2 equals to what? Equals to 0. This is for the what? For the loop 1. So we can go for the what? For what? For loop 2. For the loop what? For the loop 2. After goes for the what? For the loop 2. For the loop 2. So for the loop 2 also we have, after getting here, because it is now from positive to negative, so that's why we have negative 6 volts, and as this one it is opposite to the current, so that's why we have a positive I3, and also as that 3 is opposite to the current, so that's why we have also plus 3 I3, and also for this here and here, so we have also positive what? 0.5 I what? I2, and also we have again 0.5 plus 5 I2 again. So, and we have a positive 20 volts because it is coming from negative to the positive here. It is from negative to the positive, right? Is this coming from negative to the positive as the loop is this one? So this will come here, negative to what? To positive. Yes, it's coming from what? From negative to positive. So that's why we add 20 volts. So simply this will give us also this by 4 I2, no, 4 I3, then 4 I3 plus I2, which will give us negative 14. So after getting this, we can use the current rule. Can use the current rule. Can use here the current rule, where the current entering to a junction is equal to the current leaving the junction. So here, that's why here the current I1 is entering to this junction B, and this I3 also is entering to this junction B, and I2 is leaving the junction junction B. So that's why I1 plus I3 will be equal to I2. This is for the junction for the junction load. So here we're gonna have to find out the I3, which will be equal to I2 minus I1. So we can replace this in this equation here, and finally we have 5I2, then minus 4I1, and which will give us negative 14. So after getting this, we can make a simultaneous equation, as we have the first equation was 2I1 was 2I1 plus I2 equals to 0, and another was here is negative 4I1 plus what? Plus this negative 4I1 plus 5I2 plus 5I2, which will be equal to negative 14. So this is, we can make it as simultaneous equation, as here simultaneous equation. After getting this as simultaneous equation, this one was this one here, and we have a simultaneous equation here. After getting this as simultaneous equation, we can here also, after getting this, we can here multiply. Here we can multiply, and here also we can multiply by any number that can make it easy. So here we can multiply by 1. Can multiply by 2. Can multiply by 2 here, and here also can multiply by 1. Can here multiply by 1. Also, after getting this multiplied by 1, we can also add this equation. After adding the equation, can have, after getting this equation, can have here, this can be cancelled because we can multiply by 2 to get 4i1, and this also we can be cancelled. This also can be cancelled, and this can cancel this, and here also cancel this, and we remain with 7i2, which will be equal to negative 14. So finally we have i2, which will be equal to negative 2. So after getting this negative 2 from this equation, which is 2i1, from this equation which is 2i1 plus i2 equals to 0. So we can replace the value of i2, which will give us 2i1 then plus what? Plus, is it a plus? This minus, because the i2 was the negative 2, so that's why we have negative 2, which will give us 0. So simply i1 will be equals to what? To 1, which is ampere. So we can go to other side, which you can use that rule, which is current rule, just to find out the i3, which is equal to i2 minus i1. So we can replace the value of those one because we are given, we have found out before. So that's why i3 will be equals to i2, which is negative 2, and minus i1, which is 1. So finally we have i3, which will be equals to negative 3 ampere. So by the answer, simply i1 will be equal to 1 ampere, and i2 will be equals to negative 2 ampere, and also what? i3 will be equals to negative 3 ampere. So thank you for watching my video. So if you want to collect other questions regarding to this national exam and any other, can contact me via the WhatsApp number here and write it in a comment in order to know the problem you have. If you are satisfied by this question, can you like it, comment, and share to your friends. Thank you for watching, my dear friends. I will be happy to see you in the next video. Thank you.